Let's now proceed to finding the explicit form if the pattern of the sequence is multiplying a number. So in this discussion, I will be showing you three sets of given. So let's start with the first one. Of course, for us to make the explicit form, we need to analyze the pattern of the given sequence. So in here, by merely studying the pattern, we need to multiply each number by 2 to get the next term. 4 times 2 is equal to 8. 8 times 2 is equal to 16. 16 times 2 is equal to 32. And 32 times 2 is equal to 64. Now, here's the catch. If the number being multiplied is similar to the first term, we just have a very simple pattern in making the explicit form. All we have to do is to write a sub n is equal to whatever is the first term that is very similar to the number being multiplied to get the next term. We just have to copy that number. In this case, it's 2, and then raise it to an exponent n. That's it. So if we will try to solve this, for a sub 1, it becomes 2 raised to 1 is equal to 2, which is our first term. For our second term, that becomes 2 raised to 2, which is 4. That's equivalent to our second term. A sub 3 is equal to 2 raised to 3, and that is 8. And so on. When you continue substituting the number of the term, then you will get the next terms. So therefore, that's it. All we have to do is to erase the first term similar to the number being multiplied by n. Let's have this next example. In here we have 3 to 9, 9 to 27, 27 to 21. So by merely studying it, we need to multiply each term by 3 to get the next term. Again, first term is similar to the number being multiplied. Same process. So in here we will have a sub n is equal to the first term, which is similar to the number being multiplied, and then raise it to n. So let's try. A sub 1 is equal to 3 raised to 1, and that's 3. That's our first term. A sub 2 is equal to 3 raised to 2, and it's equal to 9. That's our second term. A sub 3 is equal to 3 raised to 3, and that's 27, which is our third term. So the pattern continues. So we have a sub n is equal to 3 raised to n. And finally, for the third example, 4, 16, 64, 256. By merely looking at this example, we can identify that we need to multiply by 4 to get the next term. Having that as an example, it's similar to the first term. So therefore, our a sub n is equal to 4 raised to n. So by checking, a sub 1 is equal to 4 raised to 1, that is 4. That's our first term. For a sub 2, 4 raised to 2, that is equal to 16, second term. And a sub 3, that is 4 raised to 3, that is 64, and that's our third term. So that's it. That's how we identify the explicit form if the number being multiplied is very similar to our first term. Now, let's move on to the next examples. It becomes different when the number being multiplied to get the next term is different from the first term, just like this example. Looking at this, the pattern says that we need to multiply each number by 2 to get the next term. So in this case, we cannot follow the process that we did in our first examples. So the pattern here goes like this. We need to do a sub n is equal to the first term, a sub 1, multiply it by the number being multiplied, which is, in this case, it's 2, and then raise to n. So if we will do this, we will now have the first term is 5, multiply it by the number being multiplied is 2, raised to n minus 1. This formula was taken from the geometric sequence. So if we'll try to solve this, we will have a sub 1 is equal to 5 times 2 raised to 1 minus 1. This is 0. And 2 raised to 0 is equal to 1. So 5 times 1 is 5. That's our first term. Next, let's have the second term. 5 times 2 raised to, this is the second term, 2 minus is 1. So 2 minus 1 is just 1. So 2 minus 2 raised to 1 is equal to 2. So 5 times 2 is equal to 10. And finally, a sub 3 is equal to 5 times 2 raised to 3 minus 1. This is 2. So therefore, that's 5 times 4 is equal to 20. And there we go. Next is this. We have the 4, 12, 36, and 108. Looking at the pattern, we need to multiply it by 3 to get the next term. Again, 3 is different from our first term. So therefore, we just have to do a sub n is equal to, the first term is 4, multiply it by 3 raised to n minus 1. That's the pattern. So when we do this, this will become a sub 1 is equal to 4 times 3 raised to 1 minus 1. 1 minus 1 is 0. 3 raised to 0 is 1. So 4 times 1 is equal to 4. A sub 2. 4 times 3 raised to 2 minus 1, and 2 minus 1 is 1. So therefore, 4 times 3 raised to 1 is just 3. That becomes 12. And finally, a sub 3 is equal to 4 times 3 raised to 3 minus 1. That's 2. 3 is 2 times 3 raised to 2 is 9. So 4 times 9 is 36. And we got the first 3 terms. Same process goes with the next one. In here, we need to multiply it by 3. Sorry, it's not by 3, but it's by 10, by 10, and by 10. Same process. A sub n is equal to, the first term is 3, write it, multiply it by your number being multiplied, that's 10, raised to n minus 1. The process continues with the previous examples. Now, let's have this next set of given. This is actually very similar to the second set. But this case, instead of multiplying it by 2, we are just dividing it by 2. Look at the pattern. These are just the reverse of the first these three examples. So therefore, in here, if we are multiplying it by 2, in here, we need to divide it by 2. And so when you express divided by 2 in fractions, it will be 1/2. Can you follow? So instead of doing divided by 2, it's better to express it in multiply it by 1/2. Same thing, multiply it by 1/2. Next, multiply it by 1/2. And multiply it by 1/2. Because multiplying a number by a half, it divides the number by 2. So, same process. Our first term is 80, and the number being multiplied is 1/2. We do the same process. So this becomes a sub n is equal to, first term is 80, multiply it by the number being multiplied, which is 1/2, raised to n minus 1. Don't forget to enclose your fraction with a parenthesis so that your exponent will include even the denominator. That's it. So let's just try if this is correct. So we have here a sub n, a sub 1 is equal to 80 times 1 half raised to 1 minus 1, that's 0, and 1 half raised to 0 is equal to 1. So this is 80 times 1, and that's 80. Same answer. Next is a sub 2. 80 times 1 half raised to 2 minus 1, and 2 minus 1 is just 1. So therefore, it becomes 80 times 1 half. 80 times 1 half is just the same as 80 divided by 2, and that's 40. And that's our second term. And finally, for the a sub 3, that becomes 80 times 1 half raised to 3 minus 1, that's squared. So therefore, when you do this, that becomes 80 times 1 over 4 because you need to distribute your exponent to your numerator and denominator. So therefore, this is also the same as 80 divided by 4, and that is 20. There you go. So once you got the first three terms, you are already secured of your formula. So you got the pattern. So let's have this next example. 108, 36, 12, 4. Same process. You need to divide it by 3. But instead of doing the division of 3 or division by 3, let's just express it in fraction form, and that's multiplying by 1/3. So this is times 1/3. This is times 1/3. So therefore, the formula will be a sub n is equal to the first term, don't forget, 108 times the number being multiplied is 1/3, and close it in parenthesis, then a n minus 1. That's it. Same process goes with this next example. So we need to divide this by 10. Instead of expressing it by division of 10, just do multiplication of its fraction form, which is 1 over 10. Same times 1 over 10. Same times 1 over 10. Let's do the same process. Since the number being multiplied is different from the first term, let's just do the usual pattern. So a sub n is equal to, the first term is 3,000 times the number being multiplied is 1 over 10, and close it in parenthesis, raised to n minus 1. And you're done. That's how we identify the formulas or the explicit form if the pattern being used in the sequence is multiplying a number. Thank you.